Hello and welcome to the channel. Today we're going to be looking at factoring polynomials. This is going to be a series of videos broken up into 6 parts. In this video we're going to look at a brief introduction to factoring, what it means, and then we're going to look at the first step in factoring videos. We're going to look at the first step in factoring polynomials, that is looking at the greatest common factor. So let's take a look at it. First of all, let's talk about what it means to factor a polynomial. When we talk about factoring a polynomial basically means to express it as a product of simpler or prime polynomials. You may recall about multiplying expressions using the distributive property. Remember that in the distributive property, or foiling, multiplying polynomials, there was, of course, the distributive property, which began with taking an expression like what we have here, 5 times x minus 4. And so the rule was to distribute or multiply the 5 by each of the terms in the parentheses. So we take 5 times x to get 5x, and then 5 times 4 to get 20. And then, of course, when multiplying binomials, there was what was known as the FOIL method, first, outer, inner, last. So in this example, 2x times 4x would give us 8x squared. 2x times 2 is 4x. Then we go inside, negative 3 times 4x, which is negative 12x. And then negative 3 times 2, which is minus 6. Combine the two middle terms to get 8x squared minus 8x minus 6. So this you've learned earlier. So the process of factoring is really taking this multiplication and going in reverse. So in other words, we're taking 5x minus 20 and working our way backwards, or taking 8x squared minus 8x minus 6 and working our way back to the original problem. All right, so now you may be familiar with doing something like this when it comes to whole numbers, like prime factorization. Recall that when factoring whole numbers, we used a method known as prime factorization, where we would take a number and we break it up, write it as a product, and maybe create a factor tree. In algebra, we do much the same thing, but things get a little bit more complicated because we have variables and exponents involved, and so we have to be careful that we're following the correct rules when dealing with variable expressions. And so factoring gets a little bit more complicated, and that's why we have a number of different steps and a number of different methods that we approach when we want to factor polynomials. So let's begin by looking at the first step that we go about when we're trying to factor polynomials, and that is looking for a common factor, or the greatest common factor. So the first step in factoring any type of polynomial is to look for a common factor among all the terms in the polynomial. So we want to look for it, factor it out. Now, this is nothing more than just the distributive property in reverse. So let's take a look at a couple of examples. So for instance, if we have 6x minus 24, note that both of these terms have a common factor of 6. 6x, of course, is 6 times x. 24, that's 6 times 4. And so applying the distributive property in reverse, we can extract the factor of 6. And then what's going to be left over is going to be x minus 4. And this is our factored form because we have a product, 6 times x minus 4. Now, we can also, common factors can also be numbers, or they can also be variables. So for instance, if we have x times y minus 3x squared, in this instance, both of these terms have a common factor of x. First term being x times y. The second term, x times 3x. So then extracting that factor, we'll have x times the quantity y minus 3x. Now, one of the nice things about factoring polynomials is that you can always check to see if your answer is correct by simply multiplying the result and seeing if you come up with the original problem. If you have a factored form, you have an answer, and when you multiply it out, you don't get what you started off with, that might be an indicator that something went wrong and you should recheck your work. Now, we have to be careful when it comes to factoring out variable factors. What if we have a case where we have a variable factor that's raised to different powers? So for instance, 5x to the fourth power minus 3x cubed plus 4x squared. Now in this instance, we can see that all of the terms have a common factor of x, but they're raised to different powers. The rule here is that we typically factor out the smallest power of the common factor. So common factor being x, the smallest power of x that we see here is x squared. So we'll extract x squared. And then when we extract it from each of these terms, we'll have 5x squared minus 3x plus 4. Now note also in this example, I had 3 terms in this polynomial. It doesn't matter how many terms you have in the polynomial, as long as you have a common factor in all of the terms, we can use this method to begin factoring. A couple of other things that we are able to do in this instance as well when it comes to factoring is that we can also factor out negative numbers. So for instance, in some instances, you may have a case where your polynomial may begin with a negative number. Say, for example, negative 12p squared plus 18pq minus 6. So in this case, the first term is a negative term. Now, we can see that the common factor here is going to be 6. And we could just factor out 6. In some instances, however, we may want to factor out the negative as well as the numerical factor. Now, when you factor out a negative common factor, in this case it'll be negative 6, think about what happens. When you distribute a negative number, you change the signs of all of the terms. So the same thing happens when we extract a negative factor. So we have negative 6. When we extract that out, this will give us positive 2p squared plus 3pq minus, or I should say plus 1. Now, this last term is going to be something that's important to note. Note that even though the common factor was negative 6, the last term was negative 6 here, but when we extract the factor, we always represent, or we always leave, when we factor it out, we'll always have plus 1, a term of 1 inside the parentheses. It doesn't just disappear. Because remember, when we multiply this back out, we have to have all 3 of those terms accounted for. One other thing that we can also do is that when we factor out a common factor can be a number, it can be a variable, it can even be a combination of numbers and variables. For instance, if we have 15a squared b to the third plus 25ab minus 20b to the fourth power. So all of these terms have a common factor of 5, but there's also a variable common factor of b. So we can, when we factor this out, we can extract both 5 and b. So this will be 5b. And then when we extract that out, we'll have 3a squared b squared plus 5a minus 4b to the third power. In addition to being able to factor out both numerical and variable terms, we can also factor out multiple term common factors. And this will transition us into what we'll be going into in the next section dealing with the grouping method. So for example, if we have 2x times 4a plus 3b minus 3y times 4a plus 3b. Note that in this particular instance, we have this entire group, 4a plus 3b, as a common factor of both of these groups. And so that we can extract the entire expression, and then what's left over will be 2x minus 3y. So we can see here that there are a lot of different ways that we can extract common factors. The main thing that we should take away from this is that we want to look for the greatest common factor first. So the first approach that we always take when looking at a polynomial, trying to factor it out, we're trying to find those common factors. When we can get a common factor, we extract it out, and then from there, if there are other things that we can do, then we'll tackle it. Now, the next thing that we want to do after we take out the common factor is count the number of terms. Now, why do we want to do that? Well, as it so happens, the number of terms that we have in the polynomial is going to dictate what method that we're going to apply to factor it out, assuming that we can factor it even more. So, in the next video, we're going to look at what happens when we have a 4-term polynomial, and we're going to take a look at what's called the grouping method for that. So I hope this video was helpful. If you have any questions, you can leave those in the comments below, and I'll see you in the next video.